The broadcast is now starting. All attendees are in listen-only mode.
Good morning, good afternoon, wherever you are in the country. It's Mark from SolidCAM. We'll be doing our 30-minute free training today. With me is Kevin Rankel.
Hey guys, how's it going?
So what we'll do today is we'll continue our ongoing series of starting from beginning to end on a part. This is the part from yesterday. If you're looking on the left side there and it looks a little different, what I've done is I just moved the coordinate systems, Mach 1 and Mach 2, to the center of the part, as per Kevin's suggestion yesterday. And I've actually relabeled my machine setups, and I actually added a machine setup for side 2 as well. So this is stuff we covered yesterday. I just moved it along a little further so we can get to today's topic, which is the actual probing of the part to set up our coordinate system. So the probe module from SolidCAM is actually a separate module. So if you don't have it and you're interested in it, contact your local salesperson and they can quote you on the probe module. But probing inside SolidCAM is pretty much what you would imagine it is. It's basically just a series of operations on the top here where you're looking for either your X, your Y, or your Z using multiple points or a single point, or like we're going to do today, just finding a boss. And if you look at it, the boss is asking us for the sides of a boss like that. And essentially, when you're doing probing, whichever one of these technologies you choose here, you actually are either finding the home position, which is what we're about to do, or measurements. And between these two, all you're really doing is collecting the coordinates of where the probe is touching. And then according to your post, according to your probe module, it'll save that information in different locations. So if it's looking for home, it'll actually save it wherever your controller saves home position. So when you touch off on it, you can set up your G54, your P1, whatever it is. With measurement, that's going to be a little more detailed to your request of the post team where that information goes. So when you do your measurement probe operation, it actually saves that X, Y, and Z coordinate and then places it wherever your particular controller, your particular software is looking to keep that stuff. So that's something you'll have to work with your post team on. But generally, the operation works the exact same way. So you choose your technology in the top left corner. In this case, we're doing a boss. And since we're looking for a boss, we have to choose geometry that is related to that. And that's basically just going to be the outside edges of, in this case, our stock. So I'll just grab one of these edges here, turn on my constant Z, and I've got my outside edge of my stock. So I'm basically outlining the outside edge of the boss. If we go to Tool, the interface is the same, but once we get to Select, we really only have the ability to add a probe. So it doesn't even give us a shape to choose from. It just asks us to choose the probe, and then we just give it our probe dimensions. I'm just going to go with the default one for now. And if you want, you can always take a look at it to see if it looks correct, if your dimensions are correct, even if it has enough of a reach. But really, all you're doing is just defining the probe for your probing operation. And then in data, you can put in your feed rate. Under levels, very similar to what you see with other toolpaths that are not based off of depth or anything like that. All you're really defining in your levels is the clearance level, where this thing's going to retract to as it moves around. There really isn't an upper level, lower level for a probe. That's basically the point of the probe. It's looking for those things. So we're really just setting up the clearance level. It's in technologies that you'll find the specifics of the toolpath, very similar to all our toolpaths. The technology section is where you're going to find the specifics. Here, you actually have it labeled as technologies, and it's calling out Tech 1. Tech 1 is just the default name for whatever this inset is over here, and this is the specifics of this toolpath. In this case, we're doing boss. So the Tech 1 is how we're going to do that boss. Let me just get a good angle on our part here. So approach / retract, that's going to be our distance there away from the part. We've got our levels here, so I can tell it where I'd actually like it to measure the Z in terms of levels. And then my reposition height is that 1 inch that we saw over there. Offset is offset from the actual geometry that I selected. So I might be choosing any geometry I have on screen. You always work with what you have on screen, but this offset will let me offset from that. So maybe I don't have a 3D model that represents my stock, but I know how much from the walls of my target I'd like to actually measure. So if I choose the outside edges of my target and then put an offset here that represents the stock thickness, I can still use the outside of the target as my geometry, and then here I can put an offset to account for that. So you always use the geometry you have in front of you, or if you don't have any geometry, you can sketch something, and even then we can do an offset off that if that would make sense as well. So there's always a way to modify your geometry. It's this last section here that we're actually going to tell it what we want to measure. So since we have a boss selection in the top left corner, I can choose X, Y, or X and Y. And you can see X and Y are going to choose those distances there. And then if I want to do multiple touches there, repetitive touches to get some additional data, we can find the median between them to get that number. All of this is to set up the actual toolpath. What's unique to the probing, though, is this eyeball up here. If I click on the eyeball, I can actually see what it is I'm telling it to do. So it's kind of like having a host CAD of a machining toolpath, but live in front of you. You can actually toggle things like, for instance, let's say my Z level. It's right at Z equals 0. So this is the Z equals 0 of my Mac 1 position 1. But since I have this set up for home position, I'm almost kind of relying on I guess, Kevin, would you say that this is kind of relying on a previously established Z, or is this just kind of actually, now that I think about it, where's this Z coming from? How does it know that Z equals 0 is this top face?
Z0 is top of your coordinate system. So now if you take that scroll wheel and go up or down, you'll actually see the movement go up or down.
Well, what I mean is, how does it know that that's Z equals 0?
Based off the coordinate system.
Based off the coordinate system, but this is setting up that home position. So how does it already know the coordinate system? Now I'm challenging you on something.
So when you guys are going to set this up, is you have to get a basic G54 position. So what we would do in our shop is I would get the probe, just eyeball it into the center and the top Z, and just get a very rough estimate of where everything is. A lot of you guys may already know where that number is, and then by putting that data in there with the safety moves in the like this, what Mark is showing us here is basically probe web, which is a probing macro code in there. So you just get it, eyeball it close, and then you can hit cycle start and run it, and then it will get the 100% accurate numbers that we're looking for.
Exactly. So it's basically like Kevin was talking about yesterday. You're going to plug in, you're going to kind of locate your stock. It might be saw cut, whatnot, and you got a general idea as where to start from. This probing will get the specific numbers, the accuracy numbers. So it'll actually locate it specifically on your part. So you get a little more accuracy there. But like Kevin said, you start from a rough position. You're probably off. You're not going to be off by a lot, because you can probably eyeball it within. I know when I worked with this guy in the shop, he would eyeball things within like 10 thou, like tenths of thou or something like that. He was pretty accurate with his eyeballs, but a lot of times you'll get the rough idea where this is, and then when you put in the safety distances in here and the offsets, you'll get the probe to come within a certain distance, and then as soon as it starts to approach, then it gets that accurate distance. So this Z equals 0 is roughly what you've eyeballed at the top of the part. You have an idea as to where this might actually begin, and then this probing will get it within the accuracy of the probe, tens of thous or 10 thou, or well, maybe not 10 thou, that's really rough, but basically it's like Kevin said. So this Z equals 0 represents the top of the part as you've eyeballed it. And then what you can do is, let's say we lower it. So I'm going to actually click on this icon here and maybe choose to go down to here. That records that Z coordinate from our little eyeballed Z. And now you can see the probe is actually going to go down to that point and then come in and record the X and the Y coordinates at that point. So this is still a lot of eyeballing, but again, you've got a rough idea that if you go down a little bit more than 300 thou, you're going to touch a face there. If it's saw cut, you know probably where you want to kind of touch it, so you get a kind of a middle ground of where a good Z location is, and then you'll be able to record your X and your Y from your part.
And another feature that they added in there is if Mark clicks where it's the negative 386, and you guys can actually use your center mouse wheel and roll that up or down as well.
Let's get a side view of that. And you can see that most times when you have this sort of prompt, you can do that sort of thing there. So you can be incremental about it. So not only can you eyeball it by clicking on the geometry, you can eyeball it here as well. And if we take a look at that, what that's going to do is it'll find the center of X and Y and give us the XY coordinate for the center of the part. And under parameters, I think, not much there.
And basically all you guys have to eyeball it is get it within a ½ inch is what we're looking for.
Yeah. Probably a good safety distance. So you're not waiting forever for this thing to approach the part and then it's not really doing it. No, -4, -0.4. Okay, so that should be a good distance. We can click save and calculate. Stock is absent from the submachine. Okay, that's different.
You don't have a submachine.
I don't. Okay, I don't know what that's all about, but it calculated it. So if we were to see that, it would actually probe and then give us our X and our Y. And now if we wanted to find or get a more accurate reading for our Z, we can go add probing operation. And we can do single point Z, or we can do angled Z. And angled Z, basically, I believe this is taking multiple points to kind of just give us a level playing field kind of thing,
Correct.
like multiple points, yeah. So let's do measurement. Let's do a Z point. So I'll click new. And it's asking for a chain. So let's grab, I guess that. Actually, looks only for a line. Okay, yeah, so let's do that. Let's grab single line.
And this depends on how accurate you guys want to be. So usually, you know, when we're just finding the Z point on something like this, we could just do a single point. Doing the Z angle is, for those of you guys that are been around CMMs, this would be kind of like scanning the top surface almost. So it will take multiple hits on that top surface. And flatten that angle out if that part was tipped up at a certain angle.
Okay, so we have our approximate ½ inch approach, offset's okay. That one there, that one there. So let's get a good view of that. So I've defined it as that line that I'm going to try and get the angle. That is in the YZ plane versus the XZ plane. Side shift, let's move in a little bit. So I don't know what the size of my probe is, but let's say we move in by, say, 100 thou.
Go minus.
Minus 100 thou. And let's we'll do it more so we can actually see it. So you can see that the side shift refers to, that's the line that I chose. I just moved in that much there. And then from the edges of that line, I don't really want to be right on the edge there, so we have these shrink geometries. So I can bring it in by, let's say, we'll do a ¼ inch as well. Come on, minus 0.25. I don't know what's wrong with my keypad today. Okay, so 0, my 0, 2.5, 2.5. No, my num lock is on, that's why. 0 point. Wow, what's going on with this thing? 0.2. No?
Okay,
we'll do it.
0.25.
I'm just going to use the wheel.
Oh, there you go.
So for whatever reason, my keypad doesn't want to work, so I'm just going to use the wheel. And oh, that's why. I guess it's a shrinking, so it doesn't take a negative number. That's my mistake. So I should have just put in positive number. So I just put in 0.25. A lot of the times inside SolidCAM, the wording will tell you what it is. So in this case, I was trying to be negative because I wanted to trim it, but there really is no need to extend it. So in this case, shrink should have been the indication there that I want to kind of shrink it or trim it by that 250. So we brought it in by 250 on all sides. And let's see, what else? We got repetitive touches. There's really nothing else there. If I do a save and calculate on that, that will measure my, my Z. That gives me an idea of between those 2 points what the Z is. Parameters, nothing there, nothing there. Okay, but it is like Kevin said, a lot of the times if you're just trying to get the Z, you can use the single point Z, and that's just going to give you that one point of contact and just record the Z coordinate. But between these two, I now have my X, Y, and my Z for this part. And if you do your probing operation the same way every single time, you can also make this a template.
Yes.
We've talked about templates before. So you can make a process template out of that. It records your probe size, your feed rates for your probe, and then the procedures you took. In this case, the boss for the X and the Y, and then my angled Z for my Z. And then I can just keep importing that probe every time I want to do it. So for instance, let's say we make a probe here, and we'll call this one probe live, and then today's date. Today is the 27th. That way, when I go to do it on the bottom side, I can say add operations from process template. There's my probe live. Click OK. We're doing this under Mac 2. Click OK. And now I have the probing operations for eventually when we go to do side 2. So anytime you find that you're repeating an operation, irrespective of the geometry, you can always load a process template, and then it loads the tools, loads the operations, and then you just have to reselect the geometry. Let's go back to our Mac 1. Now that we've probed it, let's hide that geometry there. So it's been probed, we've located it, now we can machine it. So what's the first thing we want to do to this, Kevin? We want to do 3D iMachining?
Yep, let's do 3D iMachining.
Okay, perfect. So we have a 3D model representing our stock, but if you use the box definition or any other definition, let's say the offset one or anything like that, 3D iMachining is perfect as long as you have your stock and your target defined. So if you have the 3D package, that's the toolpath I would say. Sounds like Kevin is also suggesting they use 3D iMachining. But if you don't have 3D iMachining, you can do something very similar with HSR. You can do it with 3D milling if you have it. And if you don't have any of those and you just have the 2.5D package, then what you're basically doing is choosing a series of pocketing and profiling toolpaths to do something very similar. So we'll start with the 3D tool.
Let's be all real here. If you guys don't have 3D iMachining, buy it. It's worth it.
Yeah, and this is when Kevin puts his email in the chat section so you can talk to him, and then he gets the sale.
Yeah, right.
Okay, so add milling operation, 3D iMachining, or we can go up here and we can say, let's go up to 3D iMachining. Does the same thing. Just keep in mind though that when you click up here, it adds it to the end of the list, whereas I usually like to right click on where I want it to be. So in this case, I want it to be right after this toolpath here. I'll right click, add milling operation, and it inserts it immediately after. But basically you're still adding the same toolpath, it's just where it gets added is the difference. So let's go 3D iMachining. Okay. By default, it's looking at the target, which is exactly what I want it to do. And then working area, in this case, we're going to do the entire part, so I don't need a working area. But if there was something about this part, maybe it's a really large part, or maybe I'm only really looking for 3D iMachining to act in a certain area, I can use a working area to limit the travel of the tool to a certain area that I define using a chain. But we don't really need a working area, so I'm not going to use that. Fixture collision protection, we have a fixture defined. I'm going to take advantage of that, and I'm going to say, whatever I do with this toolpath, I want the tool to stay within 10 thou of that fixture. That means that when I set up my levels, I can say the top of the stock and the bottom of the stock, and that tool should come as close to the fixture as possible while still milling all the way down to the bottom of the stock there. So I can take full advantage of the full envelope of work I have here without having to worry about colliding with my stock or with my fixture.
And
tool.
Mark is grabbing tools here. Does anybody have any questions with the probing at all? Like I said, you know, Mark went through it at a good speed here, but if you guys do have questions, definitely let us know so we can definitely address those right away for you.
Absolutely. And if you don't have the Pro module, you can always contact Kevin.
Yeah.
But yeah, the probing is very similar to our regular milling toolpaths. So it should be the same thing. Choose your geometry, choose your tool, choose how you'd like to approach the part. But overall, it's still just the same idea. You're just doing some sort of movement of a tool towards your part, choosing geometry, choosing feed rates.
Yep.
Here, I'm going to skip ahead of tool definition because I think we've done that a lot. And I'm just going to go right to my global libraries. And I think we made this thing out of aluminum. So I'm going to go to the master tool list for aluminum. I'm going to grab all the tools I think I want to use for this part. So.
And while you're where that's loading there, with the probing can do everything that a CMM can do. The only thing it can't do is any of the GD&T stuff. So if you guys are looking for a flatness call out, as well as true position, or like true position with maximum material conditions, stuff like that, it will not do. So, but it will do all the measurements, measure bores, angles, tapers, all that stuff for you. Like I said, it just will not do any of the GD&T functionality for you.
That's a good point. So what I've done is I've added a filter. So I'm only looking at flat end mills. And now I'll just do a filter to up to 1 inch. And I'm only going to go probably down as far as 0.25. So that filters the list to only show me flat end mills between 1/4 inch and 1 inch. And now I'll just click on the ones that I want. So I want that 1 inch, probably want this 1/2 inch. And then let's go down to 1/4 inch, and I'll grab probably this one. So with those 3 highlighted, I'll click on the white arrow to import only the ones that I've selected. SolidCAM blinks a little bit, and then it adds it to my active tool library. So there we are. We'll start with the 1 inch tool. So click the green check mark. And there it is. I'll add the second tool. So I'm just going to be stepping down the tool, taking advantage of the internal rest milling operation that happens when you do 3D iMachining. So the second tool is the 1/2 inch. And then the third tool will be my 1/4 inch. That one right there, green check mark. Okay, so let's define parameters for the first tool. So if I go to this little mini window here, I'll click on this first one. We can see under my tool data, do I have a holder defined? Let's see.
Should be.
From the master tool list, usually it does have the holder, so I'm just going to double check. So tool picture. No, so let's add a holder. Not that it's entirely necessary for this one, because this probably has enough reach, but we'll just go with one of the default holders. Let's go to the other tools. This one does not have a holder either, so we'll go, this one is the 1/2 inch.
Man, whoever made this library should have had this set up better.
Yeah. For those who don't know, the master tool lists for both aluminum and mild steel were created by the US-based team, specifically headed by our buddy Kevin.
And actually, this is the tool library that was at my old job that I used. So these were the tools that we had in our shop, and with all the
now it goes from being this like huge task that was created only by Kevin. Now it's just, oh, I just stole it from my old job.
Yeah. It was a huge task when I started it at my old job.
Okay, so go back to the little window here, choosing tool 57, that's my 1 inch tool. Now I can say holder collision protection. Let's keep it within, again, that 10 thou. We'll be really close quarters here. Again, for tool 57, we're gonna do levels. I'm gonna say top of stock. And then for the lower level, we'll do the bottom of the stock as well. So we're gonna go right down to the bottom, maybe even going a little further just in case there is anything that I'm not seeing there, but pretty much when you define it by the stock, it's going to eliminate all that stock. Technology Wizard, let's wow everybody by making this level 8 turbo. And then those parameters are based off of that. Technology Wizard, this is 3D iMachining. So not only do I have a wall offset and a floor offset, which I'm going to set to 20 thou just so we're not here forever calculating, we also have a scallop height. Now, normally when you're working with a prismatic part like this one, with just prismatic pockets, the scallop height's not really going to come into play because there's no tapered surfaces or curvature. Really, the only place that this is going to affect is right here, these tapered faces, which I still care about. So I'm going to make these 20 thou as well. My recommendation is usually to make these 3 numbers the same. That way, after your 3D iMachining toolpaths, every surface has the same amount of material. So that way, when you go and do your finishing, you don't have to do different scaling of finishing surfaces or anything like that. You can pretty much just use HSM on the whole thing, or you know how much material you left behind on all the faces. You don't have to think about it again. Sometimes it could be extra moves on the 3D iMachining. Sometimes it's extra calculation. But in my opinion, once this is done, you don't have to worry about it again. So the only time that this becomes a little bit of a consideration is maybe when there are certain bosses that you don't want to machine to the same offset as the walls. Maybe that boss becomes a thin wall, or maybe becomes like a little needle, and you don't want that to be too weak that it breaks. In that case, you can always use sketching or working areas to kind of limit the travel of the tool so it doesn't machine as much material around those, so you avoid thin wall or needle kind of situations. At least that's my opinion. Now, let's take a look at the overall part.
And
we've got,
before we get too much farther, let's go ahead and show them where they would change it over if there was no surfacing at all.
Oh, so top left corner, 3D General refers to the fact that this is the full three-dimensional version of 3D iMachining. It's going to look at tapers and curvature and all that. But if you wanted to do this only as prismatic, only profiles with some depth to it, you change this to 3D Prismatic, and basically what it'll do is it'll eliminate that scallop. So it looks at this only as just pockets, just the prismatic features that it has to machine. Go to 3D, okay. So in the link section, very similar to 2D iMachining, 3D iMachining is also going to do a helical entry. But what this toolpath will do is recognize that we have some outside stock, we can do some side entry, and in these cavities, it'll do the helical entry. Very similar to 2D iMachining as well. iMachining in general will look for the side entry versus the helical entry. Those are the two types that you get with 2D iMachining and 3D iMachining. So in our case, we're going to see a combination of all that. From the outside, it's probably going to do some side entry, get rid of the outside material. Maybe this pocket here, since it has that open edge, it'll do a side entry. But then for these cavities, it will do the helical entry to enter into the part and then spiral outwards. I'm just going to click Save and Calculate. And it's going to calculate with those three tools. I probably should have changed those parameters for those other ones, but essentially what's going to happen is it will add 3 tool paths, one for the first tool, one for the second tool, and then one for the third tool. Each one is a step down in diameter. Basically what it'll do is it'll work its way across the part, and then it'll get deeper and deeper into the corners. So if the first tool, being a 1-inch tool, can't get into some of those corner rads, the second tool will try, and if there's any remaining material, the third tool will try. And we have about 2 minutes left in the class. So if this takes too long to calculate, we can pick this up tomorrow. I'll take this opportunity while this is calculating to kind of do the finisher. So if you have any questions in the meantime, we will try and continue this as a series throughout the week until this part is done, until we get satisfied that we've done side 1, side 2, covered all the bases. But if there are any other questions or topics that come out throughout the week that you come up with, please, you can send us an email. Kevin's going to put my email in the chat section. We can cover those as they come along because this is a training session for you guys. So if you have something you'd like to learn, absolutely, we'll skip this for a day or for a couple minutes even, and we can address your questions, your topics that come up. In the meantime as well, if you know anybody that could benefit from SolidCAM, you can always send us their contact info or get them in contact with us. And if they get into a demo, you get that $100 Visa card. If it goes to a sale, you get 20% of the sale. And that's just free money for just giving us contact information. So think about that. Let's see, there is a question coming in. Does the probing give you X, Y, and Z so you can calculate?
Yeah, so Scott's asking when you guys use the probing, instead of using it for the home positioning, using it as a measurement, you can calculate out the GD&T for that, but you just have to do that math for it. But it will give you every point that you click on or that you tell it to hit, it will give you that point, and then it will produce that data into, it depends on the machine that you're running on, but like on a Haas, it'll be on your macro page for you, for your probe macros, and you'll see all that data in there. And then what you can do is you can capture that data and send it out to the customer if they're looking for that, or just keep it for your own. So great question, Scott. And we also have it set up, Greg Shields has been doing a fantastic job writing these probe post-processors. So what you guys can do is, let's say you guys are going off of a casting, and castings are never the same, and you set it up to probe every part. It can do that, and it will automatically change up your G54 to kind of self-align everything, as well as, let's say, when we go to bore out that center hole, we have a really tight tolerance in there. What Greg has the ability to do is you can probe that hole every single time, and it will automatically add tool comp to that tool to get that hole out the right size. So if you guys are running a big production job and you're probing every single time, it will automatically adjust that tool wear for you to keep that hole or that bore in tolerance for you guys. So does that help answer your question there, Scott? Perfect.
Yeah, good. Okay, so this is somewhat of a larger part, so it's taking a little longer than I would have liked. But what we can do is we can let this calculate outside of the class, and then I'll show you the results tomorrow. And then after this, what we can do is we can take a look at what the next step after the 3D iMachining would be, what our tool selections would be for the follow-up tool paths. So we'll continue this tomorrow. Tomorrow at 2 p.m. Eastern time. Stay safe, keep your family safe, keep busy. We will talk to you tomorrow.
All right, have a great day, everyone.